So today we're going to learn about another new test. And actually, I've got good news. This is the last test we're going to learn about for series. So.
Will this whole test later on?
No, this is the last test we're going to do.
Whoa.
We're going to talk about some applications of series after this. And then we're going to go back to some applications of integrals. Okay. All right, so we're doing absolute convergence and the ratio test. So I'm going to start by telling you what absolute convergence is. So what you do is you take, given any series, we're going to construct a new series. We consider the series where you're going to take the absolute value of the terms that are in your original series. Okay, so this series has terms an here. So if this was n equals 1 to infinity, you'd be taking the absolute value of a1 plus the absolute value of a2, and so forth. Okay? So you're taking your original series, an, and you're constructing a new series where you take all of the terms that are in your series and you put on an absolute value. Okay? So absolute convergence has to do with this new series, okay? So the definition is a series, A sub n, is called absolutely convergent if this new series is convergent. So the name kind of gives it away. Absolutely convergent makes you think of absolute value. Okay. So what if my series had positive terms in it to begin with? What happens when I take the absolute value of positive numbers? They're still positive. They stay the same, right? So if your series only has positive terms, if your series A sub n is a series with positive terms, then the absolute value of an is the same thing as an. So absolute convergence is the same as regular convergence. But we know not all series have positive terms. So if you have like an alternating series, then these two things are different concepts. Okay? So let's take and start with a series and see if we can tell if it's absolutely convergent. Test the series n equals 1 to infinity, negative 1 to the n minus 1 over n squared for absolute convergence. So here I'm just using the definition. I'm not using a test. I'm just going to put on an absolute value here. And I want us to think for a minute about what the numerator is. What are the possible values for the numerator? 1 and -1. What happens when I take the absolute value of 1 or -1? It's just 1. So that can go away. That's just going to become 1 in the numerator. And then the denominator is positive, right? N squared. Yeah, that's a p-series. Great. So this is a p-series. What's my value for p? 2. Does it converge or diverge? Converge. So the condition is p needs to be bigger than 1. So this series here converges, which means that your original series is absolutely convergent. Because that was the question, does it absolutely converge? So from here I can say my original series, -1 to the n minus 1 over n squared, is absolutely convergent. Because I put on absolute values and the series converged, yes.
Is this the test where you said that it works every time?
So we're not doing a test right now. We're just using the definition of absolutely convergent. The definition of absolutely convergent says you put on absolute values. If that thing converges, then your original one is absolutely convergent. Yeah.
Can you explain the numerator one more time? Because
Mm-hmm.
like 1 minus 1 plus 1.
So I start plugging in values for the numerator. So what do I get when I plug in n equals 1? I get -1 to the 0, 1. What about if I plug in n equals 2? Minus 1.
And then you get
1, -1, and it's an alternating series, right?
Yeah, but you just need the absolute value of it.
You need the absolute value. So what's the absolute value of the numbers in the numerator? 1. Because either the numerator was 1 to begin with, the absolute value of 1 is 1, or it's -1, the absolute value of -1 is also 1.
Yeah, but we're not adding them up prior to.
No, you're still leaving the series here. What you're doing is
So we're just looking
hold
at
on.
the sequence.
We're still doing a series. So what we're doing in this series, let me write it out so we make sure we're all on the same page. So my series, when I put on absolute values, it was -1 to the n minus 1 over n squared. So what do I get when I plug in n equals 1? We got 1 over 1. And then if I plug in n equals 2, it was -1 over 2 squared, which is 4, but the absolute value is going to make it a positive. And then it'll be 1 over 9 plus the absolute value of -1 over 16, because I can't square. 16. So you're still doing a series, but what you're doing is now I'm taking my alternating series and I'm making all the terms positive. So it's no longer alternating anymore.